In this video, I'll talk to you a little bit more about functions. You've been using functions a lot in programs so far, and just to recap, the benefits of using functions are, first of all, modularity. You can break up a large program into small chunks that are easier to tackle. Each's little chunks are reusable. If you make a nice little function, you can use it multiple times in one program, or you can use that function in other programs as well. There's something called abstraction, where you can kind of have all the details about how something works hidden from the user, and the user just needs to know how to use the function. So for example, you use the function like print many times without having to know exactly how it works behind the scenes. It makes your programs easier to debug, because if you're breaking things up into small pieces, your code can hide that detail and make it easier to see what's going on and debug the rest of the program. And you can debug each of your functions individually, and once you know those functions are working well, then you don't have to worry about that part of the code. So functions are sent some information, an object that's called a parameter. So the length function has a parameter, which is a string or a list or something else, which is iterable, and returns the length of that object. Some functions, or in this case, string methods, don't have any parameters. You just call the upper function to turn something to uppercase, but you don't need any parameters inside there. You even have had some functions with optional parameters, like the print statement. If you just say print and you give it a string, it'll print, and it'll end that print with a new line. But if you supply an optional parameter there, you can tell the print statement how to end its print. In this case, it won't print a new line, it'll just print a space. And you've seen that with range as well, that range 5 is the same as range 0, 5, which is also the same as 0, 5 with a step of 1. So all these things are equivalent, but you only need to provide one parameter, and the rest are defaults. If you don't provide the other parameters, then it will default to starting at 0 and with a step of 1, but you can override that any way that you want. So you could make your own functions have optional parameters. For example, let's say you want to give a site name to a function and have it return the full URL, the full https://www.google.com, like this. Well, many of the sites that we work with end in .com. So maybe you want to make that optional, so that if you just pass the word Google to the function, it'll just assume that .com is the ending. But if you do want to override it, like irs.gov, then you can pass it your top-level domain .gov, and it won't use com anymore. And the way you do that is you give it the variable where that parameter takes, but just put equals the default value, and that will be the default, and you don't have to send your second parameter to that function. So functions return one object to the main program. So if you have a function that you want to return what looks like two things, the square and cube of a number, when you call that function and print out the results, it'll show you that you really are returning not two separate objects, but one object, a tuple. And so this returns one object. And in this case, the parentheses are optional, but this would be equivalent to actually explicitly saying that you're returning a tuple, and you'll get the same answer. Let's say you forgot a return statement, or you didn't need a return statement. Even if there's no return statement, your function still returns something. In this case, it'll return the value none. So if I want to print the square of 13, I call this function, but I never return the number 13s, or the 13 squared, so it does return the value none. So you probably in this case wanted to return the value of x, and now it'll return 169. But there are some cases where you don't need to return anything. Let's say your function just prints out something and you don't need to return anything. Just keep in mind that the function is returning the value none back to your main program. So functions can have multiple return statements, and you probably have used this already. And this common example of this is if, in this case, we're sending a number to the reciprocal function, and it'll take 1 divided by that number, but you can't divide by 0. So in this case, we check to see if you're sending it 0. You don't want it to crash, so in this case, it'll return the string. You can't divide by 0. Otherwise, it'll actually divide by 0 and return that. So in this case, there are 2 different return statements, and that works fine. Now, in the case of, let's say you make a lot of different functions. I made a new file here called my_module. And let's say you have a number of functions that you expect that you want to use, and you compile them into one file. Instead of going into the main program and copying and pasting your function, you can just import my_module into your main program, and now you can use all these different functions. So in my_module, there's a function called myfunc1, 2, and 3, and you can just call these the same way you'd call something, let's say, if you imported math module. You can use it by making the module name dot and having the function inside there. So let's run this one. This will print this out. In my module itself, it'll call my module. So it prints the first line that says I'm running the function that's stored in a different file called a module. That's this. This was actually the result of myfunc1, which was in here. And yes, it's supposed to say, yes, it says I'm running myfunc1. So this is a nice way to package all of your handy functions together and use them without cluttering up your main program. Just import them. Now, when you're writing your functions in your module, you'll probably want to test these functions. So you'll probably want to have a few testing lines and to see if everything works. Now, you don't want these lines to be run inside your main program. These are just for testing. So there's a way to make it so that these lines are only run while you're testing this my_module file. And what you do is you say if name equals main, and these have some underscores, which are kind of ways to have hidden type variables in Python. There are a number of these that are defined that you usually don't have to deal with. But in this case, what you're saying is if my module is the main program that's being run, then it'll run these testing statements. But if it's not, like let's say here, my module is not the main program, this file is the main program, so it won't run those testing lines. Let me show you let me show you this. So if let's say I'm testing this in CodeHS, I can make this the main file. So now when I run this, I'm actually running this, not the code from main. So I'm running the module. Let's run that. And it should say testing my functions. Yeah, testing my functions. And then it calls the function 1, prints this. So this runs all these testing lines. But if we go back and make this the main file, I'm running now main. And so it didn't run those testing lines after the if name equals main statement. So that's some fun and useful additions to your program, your knowledge of functions.